Good afternoon, ma'am. I am Bea Sang-an, and today I am going to report you the topic of analysis and interpretation of assessment results in tabular and graphical presentations. But before that, let us read the objectives. At the end of the lesson, the students will be able to demonstrate techniques for showing that in graphical presentation formats, explain the different terminology in frequency distribution table, and accurately interpret data presented on a graph or a table. First, let us read tabular presentation. Tabular presentation organizes data into rows and columns, improving clarity, accessibility, and comparability. It helps identify patterns and relationships efficiently and is widely used in statistics, business, science, and research for concise data presentation. So, tabular presentation is a data of organizing and displaying data in a structured format, using rows and columns, making it easy to read, understand, and compare information. And it has a big purpose tabular presentations because it is widely used in various fields, such as like statistics, business, science, and research to present data in a clear and organized manner. And also, tabular presentation, it helps in organizing large amount of data in a structured way. So we have here a classification of tabular presentation. First is qualitative classification. Qualitative classification, this type of classification is organized as data based on attributes like physical condition, nationality, or social standing. So, qualitative classification involves organizing data based on non-numerical attributes or characteristics like gender, location, or status. Rather than quantifiable values, qualitative classifications focuses on grouping data based on descriptive or categorical traits that cannot be measured numerically, just like here in the example. In a classroom, the female students who like subject commerce is only 32 and the male is 15%, the total of 47. And and a number of students who liked science subject in a female who likes science subject is 26 and male who likes science subject is 30 in a total of 56. So as you can see in qualitative classification, this makita niya talaga ang mga students who like the subject commerce and sciences, because here in qualitative classification this focuses on grouping data based on descriptive or categorical traits that cannot be measured in numerical way. And next, let's proceed to quantitative classification. Here, data is categorized according to measurable characteristics, where the features can be quantified or estimated. So, quantitative classifications involves organizing data based on characteristics that can be measured numerically, like age, height, or income, into categories or groups for easier analysis and comparison. So, quantitative classifications is a method of organizing data in a table where the rows or columns represent categories or groups based on measurable characteristics. For example here, in a classroom, the number of students who has the weight to 20 to 25 kilogram is only 5 students, and 25 to 30 kilograms is only 18 students, and 30 to 35 weight kilogram is 6 students, and 35 to 40 kilogram is only 10 students, and 40 to 45 kilograms is 9 students. As you can see here in a column, I have example is makikita mo talaga na sa isang classroom is 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 makikita mo talaga sa isang classroom is measured nila ang aged weight, kilogram, and every student. So that's all. And next classification is temporal classification. In this approach, data is categorized based on time, which can be represented in units such as year, months, weeks, days, or hours. So, in temporal classifications, it organizes data over time using units like years, months, days, or hours as a classifying variables. Because temporal classification, it is a method of organizing data in a table, where the primary basis for grouping or categorizing the data is time. So instead of grouping data by characteristic like location or quality, temporal classification uses time as a key factor for organizing the data into rows or columns. So as you can see that here, the example here is year, and in every year it has a sale units. So in the year of 2015, the sale unit is 25%, 25,000, and a year of 2016 is 46,000, and in a year of 2017 is 70,000, and 2018 is 90,000, and 2019 is 100,000. So, makikita talaga natin na every year is tumataas yung sale ng kanilang produkto. So, that's why they used year to they used year as a key factor of organizing data because mas madali nilang malalaman that every year is gumugrow ang sale nila o tumataas ang sale nila. And next is spatial classification. So this classification is based on location with categories ranging from broader areas like countries or states to smaller units like district, blocks, villages, or town. So, spatial classification is categorizes data based on geographical locations such as countries, cities, states, or regions to organize and represent information effectively. So, spatial classification, also known as geographical classifications, because it is a method of organizing data in a table where the primary classifying variable is placed or location. So, I have here the example is presenting the population of different states in a country. So, in the states of Assam, the population is the population here is 31,205, and Bihar is 104,099, and Goa is 1,458, and Gujarat is 60,439, and Haryana is 25,351. So as you can see here that every state has a population. Pakikita mo talaga kung ilan ang population sa Assam, Bihar, Goa, Gujarat, and Haryana. So that is a spatial classification. So next is components of data table. So in a data table, it has title, column headings, rows, columns, cells, row headings, data, footnotes or notes, border lines. So these components together help structure and present data in ways that is easy to analyze and interpret. So makikita natin sa example na ginawa ko here is makikita mo ang column headings, title, rows, cells, and data. Each component like title, the title is provides a concise description of the table content, helping the reader to understand the data at a glance. And the column headings is these labels is identify the data contained in each column, facilitating quick understanding of the data context. And in a rows shows represent individuals' data entries or records, each containing values for different columns. Present as a categories of attributes of data with each column contain the same type of information. And cell is the intersection of a row and a column where specific data is stored. And a row headings Labels that identify the data within each row, often used to provide context or description for the data. And the data, the actual values of information stored within the cell of table. And footnotes or notes is explanation or clarification related to the specific data point or the table as a whole, providing additional context or insight. And the last is border lines, visual as separators that delineate the table structure, making it easier to read and interpret the data. So, these components help structure and present data ways that is easy to interpret and analyze. So, now let's proceed to graphical presentations. Graphical presentation is a highly developed body of techniques for elucidating, interpreting, analyzing numerical fact by means of points, lines, areas, and other geometric forms and symbols. It ways of analyzing numerical data. It exhibits the relation between ideas, information, and concepts in diagrams. So, graphical presentations refers to the use of charts, graphs, to visually analyze and display, interpret numerical value, clarify the qualitative structures, the data represented by a variety of symbols such as line, charts, bars, circle, ratios. So, through this greater insight is stuck in the mind while analyzing the information. So, graphical presentation is can easily to illustrate the behaviors, highlight changes, and can study the data points that may sometimes be overlooked. As a graphical presentation, it is a simple way of analyzing numerical data because it compromises a relation between data information and ideas in a diagram. So, there are the different types of graphical presentation. It has line graphed, bar graphed, histogram, line plot, frequency polygon, circle graph, stem and leaf plot, box and whisker plot. So first, let's proceed to a line graph. So, line graph or a linear graph is used to display the continuous data and it is useful for predicting future events over time. So, linear graph is also denoted as a linear graph. Are used to examine continuous data are also useful in predicting future events in time. So the line graph represents the data in a form of series that is connected with a straight line. So this series is called the markers. So that the straight line is called markers. So the example here, a line graph to show the number of hours spent reading. In Monday, and the number of students read in hours of 1 hours to 8 hours. In Monday, you read 4 hours. And Tuesday, you read 2 hours. And Wednesday, you read 3 hours. And Tuesday, you read 2 hours. And in Friday, you read 5 hours. And in Saturday, you read 8 hours. And last is on Sunday, you read 5 hours. So here, you makikita mo talaga that every day, how how many hours you spend time on reading. So through this line graph is makikita mo kung ilang oras ka nagbabasa sa isang araw or in a week. So now, let's proceed to bar graph. Bar graph is used to display categories of data and it compares the data using the solid bars to represent the quantities. So bar graph, these are used to display the categories and compare the data using solid bars. So these bars represent the quantities because bar graph is a group of data represented with rectangular bars with length proportional to the values is a bar graph. The bars can be either be vertically or horizontally plotted. So I have here an example. The bars example here is vertically plotted. So in a room, number of students 0 to 10 who like soccer balls is only 8 students who like soccer balls. And softballs, only 4 students who like softball sports. And as baseball, 5 students who like baseball sports. And the other sports is only 2 or 3 students who like the other sports. So as you can see here, in a classroom is ma-identify mo talaga kung ilang estudyante ang gusto ng mga sports nito like soccer, softball, baseball, and other sports. So now, let's proceed to the next. The next is histogram. Histogram is a graph used for quantitative data where columns represents class intervals and their height indicate the frequency of observation within each interval. So, this graph uses bars to represent the information. The bars represent the frequency of numerical data, and all intervals are equal, and hence the width of each bar is also equal. So, the example here is in the grades of English test. Then, number of students 10 to 40 students who only have score of 40 is only 15 students, and only have a score 50 is only 20 students, and the 60s is only 30 students, and 40 students who has a score 80, 70 to 80, and so on and so forth. So as you can see here, makikita mo talaga kung ilang students ang may may grado sa quiz or score sa quiz ang so now let's proceed to the next is line plot. So line plot it shows the frequency of data on a given number line. X is placed above a number line each time when the data occurs again. So each X has a one core. So again, line plot shows the frequency of data on a given line number. So the example is a number of cars sold. So each X is is one car. So in a Monday, only 4 cars sold, and Tuesday only 3 cars sold, and Wednesday only 5 cars sold, and Tuesday only 2 cars sold, and Friday only 6 cars sold, and Saturday only 5 cars sold, and in Sunday only 3 cars sold. So as makikita mo talaga dito sa araw-araw ng pagbenta ng car is that every day is makikita mo kung ilan ang nabebenta mong sasakyan. So, using this line plot is you can organize or you can easily identify how many cars in every day sold. So the next is frequency polygon. Is a graph used for quantitative data, often to display test score. Similar to histogram, it uses lines instead of bars to compare set of data on the same axis. So now, let's proceed to frequency polygon. Is a graph used for quantitative data, often to display test score. Similar to histogram, it uses lines instead of bars, compares set of data on the same axis. So frequency polygon, it's similar to histogram. It uses lines instead of bars. So In the example below, as you can see in the example, at the left side, you can see the frequency or a number of students. So, and the lower is a score of a students. So, in 0, 45.5, and 5 students only score 54.5, and 10 students who score 64.5 and 74.5, and so on and so forth. So makikita mo talaga dito kung ano ang score ng inyong estudyante. So through this frequency polygon, it helps to compares data in the same axis. So now let's proceed to circle graph. Circle graph, also known as a pie chart, that shows the relationship of the parts of the whole. So, a circle graph is a way to show how different parts make up a whole. Imagine a pie where each slice represents a portion of the pie. Each slice is usually shown in different colors, and the size of the slice show how big that part is compared to the entire pie. So, the whole pie, this represents as 100% of the things you're looking at. For example, if you're looking at the pie chart of your day, the whole pie represents your entire 24 hours. And each slice shows how much time is used for different activities. For example, one slice could represent how much time you spend on sleeping, another could be working, and another could be eating. So, each slice often has different color, making it easy to tell one part from another. So the example below is time, how much time you spend in daily activities. You can see there that work is 40%, eat is 8%, sports is 14%, and bath is 6%. And watching TV is 7%, and sleep is 25%. So the chart visually shows you the proportion of time for each activity. If you see a big slice for work and a small slice for leisure, it's easy to understand how much time is spent on each activity. So now let's proceed to stem and leaf plot. A stem and leaf plot is a way to display data in a graphical format, which helps organize and visualize the distribution of numerical data. It is similar to a histogram but represents the actual data values instead of just frequency. So a stem and leaf plot is a way to display data to make it easier to see patterns and understand numbers. So, a stem, these are the big parts of the numbers, usually representing the tens place. For example, if you have the number 42, the stem is 4, since 40 is the main part of the number. And the leaves, these are the small parts of the numbers, usually representing the ones place. So in the number 42, the leaf is 2. Let's say for example here, the example below, the following numbers is 32, 34, 41, 42, 43, and 51, and 53. So the 3 as a stem shows the number in the 30s, and the leaves 2 and 4 shows the number 32 and 34. And the second is 4 stem shows the number in the 40s with leaves of 1, 2, 3, showing the numbers 41, 42, and 43. And in 5, 5 stem shows the number in the 50s with leaves of 1 and 3, showing the numbers of 51 and 53. So, stem and leaf plot is a simple and clear way to organize and display data for us to making it easier to understand and compare numbers. And now, let's proceed to box and whisker plot. A box and whisker plot is also called a box plot. Is a graphical representation of a data set that shows the distribution of data based on a 5 number, which is the minimum, first quartile, median, third quartile, and maximum. So a box and whisker plot, also called a box plot, is a way to show how data is spread out, and also it helps you to understand where most of the data is, where the extreme, very high, or a very low numbers, and how the data is balanced. So I have here a video for you to watch so that you can understand more the box and whisker plot.
So let's do a quick review. First, we determine the minimum, the smallest number in the list. Then, the maximum, the largest number. After making sure that our numbers were listed in order, we eliminated pairs of numbers, starting with the first and last and moving inwards until we found the middle number, the median. Our next step was to find the lower quartile, also known as Q1. To find this, we found the median of the lower half of the numbers. The lower quartile, Q1, is equal to 180 pounds. And to find the upper quartile, we find the median of the upper half of the numbers. The upper quartile, Q3, is equal to 204 pounds. Looking at our numbers, 272 pounds seems much larger than the other weights, so we should definitely check to see if there's an outlier. To do this, we'll need to find the interquartile range first. Interquartile range is equal to the upper quartile minus the lower quartile. 204 minus 180 is equal to 24. In a previous video, we learned that small outliers are less than the lower quartile minus 1.5 times the interquartile range. This will create a lower fence that we will need for our display. The lower fence is equal to 180 minus 1.5 times the interquartile range, 24. The lower fence is 144. Large outliers are greater than the upper quartile plus 1.5 times the interquartile range. This will create an upper fence needed for our display. The upper fence is equal to 204 plus 1.5 times 24. The upper fence is equal to 240. Because 272 is above our upper fence, it is an outlier and should be displayed in our box and whisker separately. Let's start to create the box of our box and whisker plot by creating a scale from 170 to 280 to fit all of our values. We then create our box by putting a line at 190 for our median, a line at 180 for our lower quartile, and a line at 204 for our upper quartile. We close the box by joining the three lines. Since none of our values go below the lower fence, we draw a line at 173 to represent the minimum and make our first whisker. Since we have a number higher than our upper fence, we indicate it separately with its own marking. If we had additional outliers, each would have their own marking. Now, we can create the endpoint of our second whisker with the highest value within our fence. And this is what our final box and whisker will look like. Here's what we've learned. A box and whisker displays the minimum, maximum, median, lower quartile, upper quartile, and each outlier.
In conclusion, tabular presentation are highly effective for displaying accurate data and enabling detailed comparison across categories, offering a clear and concise view of the information. This makes it easier to identify patterns, outliers, and key insights, while also saving space, simplifying comparison, supporting statistical analysis, and reducing errors. On the other hand, graphical presentation excel at visually representing trends, patterns, and connection in data, making it more accessible and impactful for a broader audience. They enhance understanding and learning by simplifying complex information. And that's all. Thank you. Thank you for listening.